everyone, in this video we're talking about what is a probability, so an introduction to this concept. One way you can think about probability, sort of an intuitive definition, is just a measure of how likely an event is to happen. And something important to remember about probabilities is that they are always between 0 and 1. We sometimes write probabilities as fractions, sometimes as decimals, sometimes we give them as percentages, but they're always going to be some sort of fractional value between 0 and 1, including 0 and 1 themselves. The probability of 0 represents no probability, meaning that the event is literally impossible. There's no chance that it could happen. Versus a 1 means that the event is guaranteed to happen. It definitely will happen. So for example, an event with 0 probability would be drawing a black card from a deck with only red cards. Right? If there's only red cards, it's impossible to get a black card. Or flipping a coin and getting both heads and tails. We could get heads or we could get tails, but it's impossible to get both at the same time. An example of an event with probability 1 would be rolling a standard die and getting a number between 1 and 6. Those are the only possible outcomes, so you're guaranteed to get some number between 1 and 6. Sometimes we use probabilities in kind of an intuitive sense. So if a friend asked you how likely you are to get a job that you applied for, you might use kind of your understanding of the job market and your own skills to estimate your probability. And often we estimate probabilities in sort of a percentage context. So maybe I'm pretty confident about getting my job. I'm going to say that I estimate my probability of getting the job at 70% or 0.7. Another way we sometimes find probabilities is using empirical data. So if you open up the weather app on your phone or watch a weather forecast and look at the probability that it will rain tomorrow. So that is a number, again, usually written as a percentage, but a number between 0 and 1 that indicates how likely the rain is. And those aren't just pure guesses, they're based on sort of knowledge about the climate in that area, as well as, analyzing the wind speeds and pressures and things like that. So I might look at my app and see a 26% chance of rain. That would be a probability of 0.26. So all of these probabilities between 0 and 1, it's not saying that we definitely are going to have rain or that we definitely won't have rain, but there's a 26% chance that that will happen. A more precise definition of probability is the long-run relative frequency of an event. So if the chance of rain is 26% or 0.26, that could be saying that under these particular conditions, if we had a day with these exact same conditions over and over and over and over and over and over and over, maybe 1,000 of these days with these conditions, in 26% of those days we would have rain, and in the remaining 74% of the days there would be no rain. I want to kind of visualize this with an experiment. So I'm using this great visual tool from Staplet.com, Staplet.com. And the website calls this one the Law of Large Numbers demonstration. So here we're looking at a teacher named Mrs. Gallus, and she's making free throws with a basketball. And in this setup, the true percentage of free throws that she makes is 75%. So the probability that on any given throw she's going to make it in is set at 75%. So if I shoot, I have a 75% chance of getting it in, or she does, and a 25% chance that it won't make it in. Now on any given throw, obviously either she makes it or she doesn't. So on this first throw, she did make it in. That plot shows that 100% of the shots made it in, since there's only been one. If I throw another one, made that one in too, so 2 out of 2 made it in, that percentage made is still 100%. So this is not matching the theoretical probability of 75%, but that's because we only have 2 throws. In fact, with 2 throws, you either have 100% in, 50% in, or 1 out of the 2, or 0%. If I throw again, made it in, still 100%. And I can keep doing this. I'm expecting that most of, oh, I got a miss. Most of these shots are going to make it in because 75% is our probability. At this point, I've made 5 shots. 1 of them didn't make it in, so that's 80% made. Again, 80% does not match our 75%, although it's getting a little bit closer. If I keep doing this, we made another one in, so 5 out of 6 is 83.3%. Made another one in, our percentage is climbing. But if I do this over and over, I should eventually see these percentages get closer to 75. So at this point, I've made 11 shots. 9 of them made it in. That's a percentage of 81.8. Let's quickly take 50 shots. And you'll see that, again, we started with 100%, it dropped back down and then kind of crept up again as we made more baskets, dropped back down when we missed one, crept back up. So we have some little trends within the data, but over time, as we've reached, it looks like about 60, the percentage is getting pretty close to 75%. Right now, after 61 shots attempted, the percentage made is 73.77. If I do 50 more, and 50 more, and 50 more, I've now made 261 shots. 197 out of them made it in, so that's 75.5%. So this is what we mean when we say the long run relative frequency. So in the long run, in theory, when you made infinity shots, keep doing this forever, the percentage that make it in should be 75%. That's what a 75% probability really means. But if I look at just a few, so if I do, in this case, let's see, 15 shots, that this group of 15 ended up with 73%, but another group of 15 might have a different percentage. So there's randomness involved here. You wouldn't necessarily expect to see 75% on any given small number of baskets. So this was just an overview of what a probability represents. There's 2 main ways that we calculate probabilities. One is using experimental data. So in that basketball scenario, we set the percentage at 75%, but in reality, for a given basketball player, you don't know what the true probability of their making a shot is, and it probably depends on lots of things. But we could use some data, collect, how many baskets did they make over 1,000 shots, and use that relative frequency to estimate the long run probability. And the second option that you'll be focusing on in these few sections of this chapter is using some theoretical constructs like sample spaces, the concept of probability independence, and conditional probability. And we can use that to build up our probability tools or calculate what the probability of any particular event is, at least under certain circumstances. That's it for this video. Thanks for watching.